Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is an MCQ about biomolecule synthesis. Why I am saying about biomolecule, we will know later on. So, you can see the question in front of you and you have to say what is the major product of this reaction. Here, 4 options are provided and one of them is the right answer. I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. Remember, self-evaluation is essential for improvement and that's why you should try. Now, after some time, I'll get definitely the right answer. I believe you have tried by yourself, so it's my turn to give you the right answer. Student, in reality, this is a 2-step reaction and this is the reactant. When such kind of scenario appears, one of the strategy is first look at the reagent and the reaction in the first step. Okay, so this is actually, you may consider alpha beta or this gamma delta unsaturated carbonyl, and in this case, remember student, in case of carbonyl, this carbonyl carbon is the strongest electrophilic center. Why? Because it is directly attached to the electronegative atom oxygen, so it has the maximum delta positive charge density, means it is the most electrophilic center. Now, sodium ethoxide and this bromoester, alpha bromoester. So, what type of reaction condition? Darzin's reaction, I have already discussed. So, what it does is base, this is strong base, it will abstract this proton and ultimately it will produce an carbon ion which can act as a nucleophile. So, let's learn the mechanism stepwise. So, in the first step, in presence of this base, what it can produce? It can produce this negative charge. These negative charge is stabilized either by the minus I and minus R of this CO2Me and second minus I of this halogen. Fine. So, this is relatively stable and it will act as a nucleophile. It will attack here and it will open up. So, it will produce this beta alkoxy derivative, halo containing derivative, and we know that in case of Darzin's reaction, what happens in the next step? It attacks here through intramolecular SN2 type reaction. These bromo leaves because bromine is a good leaving group and ultimately it produces epoxide, this part. Not only that, if you look at this part, this bromo is alpha bromocarbonyl. Okay, and we know these alpha bromocarbonyl are good for SN2 type reaction, I have already discussed. So that's why this reaction will happen very easily and produce this 3-member ether called epoxide. Now, in the next step, is this sodium methoxide methanol. I mean, you can say this sodium hydroxide methanol and heat. So what happens? This part you may consider ester hydrolysis type reaction. So what it can do? These OH can attack this here, this OH. So it will open up, it will come back and it will leave. Now in that case, everything is same. Just this part, what will be the fate? This will be OH, just these parts. OH, reaction medium is still alkaline hydroxyl. So what will happen? This proton will be abstracted because this is acidic proton. So it will produce this carboxylate derivative, and obviously sodium is the counter cation here. Now in the next step, what you can expect, that heat is given, heat. So under heating condition, decarboxylation is preferred. So you can expect that it will push, it will open up, come back, and negative charge will come here. Fine. Actually negative charge doesn't come here. So in this step, what is this? This is simple decarboxylation or CO2 elimination. You have understood. Now in the next step, so it will come back and these negative charge will come here. Consequently, this bond will open, carbon oxygen, because epoxide is a strained molecule. So what it will produce? See, this part remain as it is. Fine, this part remain as it is, and here only one double bond, this. So this is the double bond, and after opening of this oxygen, it is carrying this negative charge. Fine. And what is this, student? This is nothing but enolate. I have already discussed this part, and it can undergo tautomerism. And what it result? This instantly tautomerizes to the corresponding, what student? The corresponding aldehyde. Now here one part, just count the carbon. So this part if you keep intact, so this is, after that how many? Actually 3 carbon. One is methyl, this is methyl, and another is aldehyde attached to this central carbon. So this is exactly the same. So what is the product? This is the product, and what are the key steps and name reaction associated here? First is Darzin's reaction or Darzin glycidic ester condensation. I've already discussed this thing. Second thing is ester hydrolysis part 2, and means this to this, and next step is heating decarboxylation and this epoxide opening, means decarboxylation and epoxide opening simultaneously will happen. It will produce this enolate derivative, and last step is ketoenol tautomerism to produce this. Now if you look at little carefully, student, in this Darzin reaction, means using this Darzin's reaction, what you can do, one ketone, this ketone could be converted into this part, means this oxygen could be replaced by one aldehyde. So this is, you can consider a strategy to convert ketone to aldehyde with 1 carbon excess. Okay, so this is another strategy, but this molecule has some interest, that's why this reaction is done. We shall come after some time. So here what is the right answer? Right answer is one aldehyde with at this position of oxygen. So option D is the right answer. Now if this question is provided in your exam less than 30 seconds, how can you conclude the right answer? First of all, you need to understand what is the reaction condition and what are the reagent, Darzin's reaction. So what Darzin reaction produces? Darzin reaction produces an alpha beta epoxy ester, fine. And the second step is, and I suggest you student, please write the product of the first step here, and then look at sodium hydroxide, methanol, heat and CO2 elimination is mentioned. So here a simple calculation that CO2 elimination is mentioned, so there will be 1 carbon less. So only 1 carbon will be added here. Okay, and so consequently carbon less not possible. I did not give any oxidation such that this double bond you can break like ozonolysis and you get no. So option A initially gone. Option B, this is Darzin's reaction, and here carbon actually less, means if you have to add this reactant and this carbon, and later on you have to reduce 1 carbon because CO2 elimination is happening, but this also doesn't matches here. And in this case it is true carbon number is same but position is different. Why? Just a simple thing, this nucleophile is student harder in nature, this carbanion. So this is hard in nature, so it will attack on this carbonyl group, not the beta carbon. So that's why this option is also gone and the right answer is remaining. Okay, this is little tricky, but with proper practice and study you can come up very fast to the right answer. So let's come to the importance of this compound, this beta enone ring. Why it's important? It is used for industrial synthesis of vitamin A or retinol. So this is vitamin A. Why retinol? This all because of this alcohol. Just look at this part we are talking. Okay, so that's why this chemistry is interesting. Now in conclusion, what you have learned today, that bromoester's alpha hydrogen is significantly active or acidic due to the minus I effect of bromine and the minus I and minus R both of this CO2 Me star. In conjugation with the conjugated carbonyl compound, the carbonyl oxygen is most electron deficient because it's directly attached to the electronegative oxygen atom. And remember, the acid base reactions are the fastest compared to nucleophilic addition, and this alpha bromocarbonyl is very active substrate for SN2 reaction because the intermediate, this coordinated species with negative charge, is stabilized by the withdrawing effect of this carbonyl. I have already discussed a dedicated lecture on this, exactly this topic. And remember, 3-member ring formation is associated with proper conformational orientation. That's why they form, but they have a problem because of angle strain. Okay, and the last point here is in ketoenol tautomerism, the equilibrium prefers to remain to the carbonyl side because this carbonyl is more stable, means this keto is more stable compared to enol, or these C double bond O is more stable compared to this C double bond C. That's why the equilibrium will prefer to remain to the keto side. So this is the end of this discussion. I believe this video may be useful. I thank you everyone for watching this video. If you really consider the content of my channel is worthy, then please help this channel to grow. And if possible, please visit my other channel where I upload global warming and climate change related videos. So stay happy, stay blessed. See you in my next video. Bye bye.